4.2 Scatter plots and trends. So which point represents who? Well, for that, you have to look and know how to examine a scatter plot. So you can see a little plot here with some points. On my y-axis, I have the age of these people here, and on the x-axis, I have the height of these people here. So when you look at, let's say, the point number 7, it is the point that has the smallest height because it is closer to the origin. This is closer to the 0. So it's the smallest height, as well as it's the smallest age. There is no one that's higher. There's no point that's lower than the 7, and there's no point further left of the 7. So it's the smallest height, smallest age. So that could correspond to um, a kid, or yeah, you know, and it could be Kathy, or it could be something even smaller. Could be that baby being held in this person's hands. So I'm going to say number 7, smallest height, smallest age. Okay. What about number 6? 6, a little bit tall, a little bit older than number 7, just a little bit older, and also maybe a little bit higher than number 7 as well. So we're looking at maybe the next highest person and the next oldest person, which would be the little kid here, Kathy. So we're going to say Kathy is number 6. Okay. Now let's look at number 1 and 4. Okay, so number 1 and 4, they're on the same. Like if I drew a line, like let's just draw a dotted line like this. You might notice something that it's a straight line down at the same height. They have the same height. 1 and 4 have the have pretty much the same height. Okay. What about age? Well, age, they have different ages. So one's going to be a lot older and one's going to be a lot younger. Okay. So I'm looking at so two people who have the same height. So the next highest height above Kathy would be these two folks here. So Dennis and Brenda. Well, Dennis carrying a cane, balding. Chances are he's much older. Brenda much younger. So Dennis here is going to be the older one at number 1, and we're going to have Brenda here, the younger one, at number 4. Okay. Then let's look at the next person. So 3 is the next one that's a little bit taller than number 1 and 4. So who's taller than Brenda and Dennis? Looks like Frida would be a little bit taller. Okay, so Frida would make sense to be number 3. And then we have number 2 and 5. So again, number 2 and 5 look like they line up on the same line. Okay, and it looks like 4 and 5 are the same age. So 2 and 5 are the same height. So we have Errol and Alice, which look like they are the same height. So the question is, which one is more likely to be the same age as Brenda? So maybe Errol looks like a younger person than Alice, and could be on the same age range. Just could be a lot taller. So we could say Errol would be number 5 here, and Alice would be number 2. Okay. So we just did a little analysis on scatter plots. Where would you fit in this scatter plot? So let's go through some definitions that we need to know. So positive correlation. So if a scatter plot slants, so we're talking about all the data values in the graph here has a little slant upward. We can say something about that. You can say that as you move from left to right, the two variables are said to have a positive correlation. So if we see the data, which we see here is sort of trending upward, it's going up, we have a positive correlation. If the scatter plot slants downwards, we're in a situation that as we move from left to right, the two variables are said to have a negative correlation. Okay. If the scatter plot shows no relationship, then we say we have no correlation. Meaning if the points are just scattered everywhere without anything that looks like a pattern, then there's no relationship. Okay. Correlations could also be strong or weak depending on how close are those points to each other. How close are they clustered together? So for each of the following, determine if the relationship has a positive, negative, or no correlation. So as we sweep from left to right, you can see in part A that the points tend to go downward. So if they go downward, we say that this is a negative correlation. Part B, as we sweep from left to right, you can notice the points are going upward. So this would represent a positive correlation. Okay. What about part C? So again, as we sweep from left to right, the points are going upward, and there's a little bit of the points that are really closer, much closer to each other, so it's going to be a little bit stronger. But this is also a positive correlation. Look at part D. Is there any correlation here? Well, they seem to be neither going upward or going downward, just mostly staying in the same line, but they're scattered around. I mean, we're also going to say for this one that there is no correlation. Here we have, as we go from left to right, they're going points that are going down. They're going down, so we have a negative correlation. So what about this one? This one looks like, well, maybe you have some points here going up, and the points are coming back down. Positive, then negative. Okay, but as a whole, we don't see one linear pattern. We'll say it's a non-linear pattern because we don't see any kind of straight line going up or down in one direction. It's going up and then down. What about here? We see a nice straighter pattern here going down, so it's a negative correlation for part G. For part H, maybe it's slightly negative. It's just sort of inching downward as a whole trend. So we can just say here, slightly negative. For part I, we see an increasing trend here, so it's positive. For part J, not much of a correlation, just a group of points. So I'm going to say here, no correlation. Here again, we have a scattered bunch of points, no correlation. What about this one? Could be going down, but there's a huge jump from here to here. There's not enough information for us to really tell. So we're going to say here, too few points to tell. Okay. So for each of the following, determine the independent variable and the dependent variable. Part B, sketch a potential scatter plot of the relationship, and determine if the relationship is a positive, negative, or no correlation. Okay, so number one, the number of school days attended versus the number of pages left to do in a math text. So the number of school days attended, well, as you start from the beginning of the school year, this only goes up. And the number of pages left to do in a math text. So as you start a math text, the number of pages tends to go down. Right? As you go from one page to the next, you have less pages to do. So if I were to plot a scatter plot of this, I'm just going to draw some axes like this. Oh, wrong way. I can turn it around like that. Okay, good. Let's move that up. Okay. I can say, what would be my independent variable? What would be on the x-axis? Well, it would be the number of school days, right? Because that's arbitrary. You just count from one day to the next. So on the x-axis, I'd have the number of school days. What about my y-axis? Well, the number of days, maybe the number of pages left to do in the math text may depend on what day of the school year it is. So the number of pages left would be the dependent variable. So number of pages left. Okay, and so dependent variables go on the y-axis. Independent, the ones that stand on its own, goes on the x-axis. Okay, so as the number of school days goes up, and I have the arrow going up, the number of pages should go down. So if I start off with Scatterplot here, you start off with a high number of pages, but as you go throughout the school year, you should be able to reduce the number of pages until you're completely done. So what kind of correlation would this be? You have negative correlation. Okay, and why? Well, you can explain it here as the number of school days goes down, so you have the number of school days. So when one increases, the other decreases, and vice versa. So the number of school days increases, the number of pages left would decrease. So a number of pages. Okay, in some situations, it might be the way around. And something decreases, the other thing might increase. In this situation, it's one when the number of school days increases, the other one decreases. Number 2, outside summer temperature versus the sale of cold drinks. So you might think, well, temperature pretty much stands on its own. We have no control. Temperature just happens, right? Whatever day it is, temperature is the temperature. The number of drinks sold, however, might depend on how hot it is outside, right? Because if it's more hot, people get thirsty and people will start buying more drinks. So I'm going to say my independent variable, my x-axis variable, is the outside temperature. And the sale of cold drinks would be my dependent variable. So sale of cold drinks. So when would you think you'd have a larger sale of cold drinks? Well, when the temperature is much higher. So here on my x-axis, you have not 0, but if it's a higher temperature, hot temperature, you're going to have points up here, corresponding to more sales. Okay, when your temperature is lower, maybe people are not as thirsty, so the sales of the drinks are down. And somewhere in between, you have some more points, creating your scatter plot. So this kind of a relationship is a positive one. It's a correlation that's positive. Okay, so why? Because when summer temperature increases, what happens? The sale of cold drinks also increases. Number 3, the size of a person's hand and the amount in that person's savings account. Well, does that make any sense? And let's try and make a scatter plot here. So if you have a size of a person's hand, okay, maybe you can control that. So size of a person's hand on the x-axis on the independent variable, and the amount in savings. Is there a correlation? Probably not. So you might have no relationship. You might have a series of points all over, scattered around your graph, neither making a positive or negative trend. So here we have no relationship. Number 4, the number of pages left to be read in the book versus the number already read. So for this one, I'm going to draw another grid, axes, perpendicular lines here. So number of pages you already read, that's what you can control. So that's going to become my independent variable. Number of pages read. How many pages left would be my dependent variables. How many pages left? So this needs to be obvious because how many pages left to read depends on, it depends on how many pages you have read. And how many pages you have read is something you can control. So that's my independent variable. Okay. So as you start from page 1 and you increase the number of pages you read, there's going to be less pages left for you to read. So at the beginning, when you only read like one page, you have like a lot of pages left to read. So you're somewhere up here, right? You just start reading more pages, you're going to have less and less pages to read. So your graph's going to go down, right? So here, like at the beginning, when you have read very little pages, you have a high number of pages left. Down here, when you have read most of the book, you have a smaller number of pages left. This is a negative correlation, negative trend. Okay? Negative. So as the number of pages already read increases, the number of pages left decreases. And that ends this lesson.